user-defined variable names, user-defined functions. So what is a user-defined data type? A structure is one such user-defined data type in C, which we shall learn in this video. Watch the video till the end to know about the syntax of declaration and usage, the member selection operator, typedef and more. So what is a structure and what is its need? Like I said, a structure is a user-defined data type which allows you to group different data types under one name. Whether it is fundamental data types or derived data types, they let you store elements of the same data type, homogeneous data type. But here in a structure, we can have elements of different data types and it can be referred to by a single name. And the members of the structure, they occupy contiguous memory location, and this data type plays a very important role in representing real world entities. This is a example that's to show the way of declaring a structure. The keyword struct, and then this is a tag name which is the data type. So here student is the data type that is followed by a set of curly brackets within which we refer to the members of the structure. So here we can see we are having elements of different data types. I have an integer, I have a string, I have a float. So all these different data types, they comprise together to form our new data type student. And here I have declared a variable s1 of type student. So at the end of defining the structure, the tag student, I can declare my variable like this before the terminating semicolon, or after the data type has been defined, subsequently I can use the keyword struct, the tag name or the data type, and then declare a variable. Two ways of declaring a variable. Thereafter, to refer to every member of the structure, we use a member selection operator, namely the dot, s1.role, s1.name and so on. Now to declare and initialize statically, there are two forms. So along with the declaration, I am to initialize, which is shown here. So with the assignment operator within a set of curly brackets, following the same order of the members that were declared within the structure, I will have the initial values given, or I will declare the variable s1 of type student and then individually assign values to the members of the structure. The operations that are possible on a structure, the assignment is the only operation possible on a structure. So if I have a structure variable s1 assigned with some values, and I have a different variable s2 assigned with s1 will allow s2's members, roll number, name and marks to take exactly the same values of s1, which is same as independently assigning the values of the members. So all these statements together can be equivalently written as one statement, s2 equals to s1. And very important to notice, arithmetic relational operators are not possible on structure variables, but they are possible on members of the structure. Now a nested structure is where we have a structure within a structure. So here the main structure is student, which has got the members, roll number, name and marks. In addition to these members, I have a variable which is of type structure. So the structure that is nested should be defined or declared before the structure which is to nest it. So address is first defined, which is to have two members, an integer and a string, and this structure variable is shown as a member of the outer structure. And thereafter to initialize, look at the syntax. So for the direct members we do this, and for the nested member we can have the set of curly brackets, which is actually it's optional, but it's easier to understand to have a set of curly brackets within to represent the nested structures elements. And thereafter to print the details of the members, it's important to note the way we refer to the members. So it's variable dot member using the member selection operator. When it comes to the nested variable a, then it's the outer variable s1 dot inner variable a dot the member h and o. So the syntax of referring to the nested members is important. Now array of structures, a structure can have an array within as a member, and we can have a array of structures for the data type that's defined. So here my student has got just two members, integer roll number and integer array, and here this s of 50, this refers to a array of structure of type student. If I have to separately declare, then the syntax is like the keyword struct, the tag name student, the variable and the size of the array. And thereafter to read, the outer loop is to traverse for the number of students. Okay, if you have 50 students, the outer loop should have traversed till 50, and the inner loop is because I have a array that is a member of the structure. So the elements for the 5 marks are read using the inner loop. The word typedef. The keyword typedef is used to create an alias. So if I have a statement as this, now thereafter what I mentioned after the curly bracket stud is no longer treated as a variable, that is treated as an alias for the data type student. So without the typedef, after the curly bracket what I mentioned will be treated as a variable, but with the typedef preceding struct, the name that I have mentioned here is going to be treated as an alias for the data type student. So thereafter I can declare variables either using the original data type as struct student s1 or using the alias as student s2. Both will refer to the same data type. So typedef is used to create alias names for a user defined data type. In fact, you could use a typedef for a fundamental data type, derived data type also. Typedef is generally used to provide an alias. The next topic is about structures and unions. Union is yet another user defined data type. The difference between a structure and a union is, in a structure separate memory is allocated for each member, but in a union there is a shared memory for all the members of the union. So obviously the structure size is going to be more than a union size. So one example is shown here. The members are the same. I have a integer and a string, but what my s1 size will be is a 4 plus a 20, 24 bytes. But for the union, the member which has got a bigger memory allocation, that will be the final allocation for the entire variable s2. That 20 bytes is going to be shared between the members of the union, roll number and name. When it comes to using a pointer in a structure, a normal structure has been defined, a data type student has been defined, and a normal variable has been declared and initialized with some values. Now to declare a pointer of type student, the keyword struct, the tag name student, asterisk, the pointer variable assigned with the address of the normal variable. And thereafter what is important to notice is the member selection operator syntax. For a normal variable we'll use a dot operator to refer to the member, and for the pointer we'll use a arrow operator as a member selection operator. Let's look at one sample code. So here I am to read and display the students in descending order of marks using a user defined function. So I have a data type struct defined, which has got two members for now, roll number and total. I have a preprocessor directive hash define, which is defining n2 store of 5 for now. So this is going to be an array of 5 students. So we'll have one UDF probably to read elements for the 5 students or the n students. So my formal parameter is going to be of type student, and it's going to be an array that I'll pass. So I can use this notation for representing a formal parameter to be an array, and we'll have the size of the array passed as well as a second formal parameter. So for that many elements I'm going to have a loop, and within the loop I'm going to ask for the details from the user. So let's say enter roll number and total marks. Let's give a common prompt, and for both the values we'll have a read happening here. Both are integers, so I'll have a format specifier and read the elements as x of k dot roll number and address of x of k dot total. So the elements for the array has been read, and if I have to call the function, it will just be the function name. The function is not returning anything, it's a void return type. So I have to pass the structure, that is a uppercase S, and the size. I've included another user defined function display, which also takes the array of type student and the size, and in a tabular form I am trying to display the elements of the array of structure. Using a third UDF, we will have the elements of the structure sorted in descending order of total. So we will use a bubble sort where the outer loop I will traverse until size -1, and the inner loop we shall traverse j less than size -k-1. Every time the comparison is going to be, so we just saw operations on structure variables can only be assignment, but operations on the members of the structure can be all relational arithmetical operators and so on. So we shall have the condition to be checked as every x of j total, we want descending order, if that's less than or equal to the j plus 1 total. So in that case I'm going to do the swapping. So we'll have one temporary variable of type student declared here itself. So when we do structure assignment, both the variables should be of the same data type. So here my temp is going to store x of j wholly, x of j is going to store x of j plus 1, and x of j plus 1 is going to store temp. So that will have the structures elements sorted in descending order of total. So out here in the main I could have the elements shown before sorting by calling the function display the array and the size, and I could have the same call happening after sorting. And have the function call done again. So let's execute and see. So let's give input for the n students. That's the roll number, the total, roll number, the total, roll number, the total, the roll number, total, the roll number, and the total. So before sort, the data is as entered by the user, and after sort the data is arranged in descending order of total. So we have learnt when arrays are passed to a function, the operations done within the changes made to the array within the function are automatically reflected in the actual argument, because arrays, they're always passed by reference. So this is a simple example involving UDFs to see the way of declaring a structure and using structures in a UDF as well. More codes on structures have been listed out here. The solutions for all these are available in the GitHub repository, whose link is shown, which is included in the description also. Please do have a look. Do like, subscribe for more programming tutorials. Happy coding!